Alright, so this is the second side of the notes, and the first page we used a table to make a function, and on this page it's going to be how use a graph to make a function. So our main idea in this case, same as before, and the steps are going to be exactly the same. In the previous video I didn't summarize the steps though, and so let's go ahead and summarize those steps because they're going to be the same steps we use this time. Alright, so the first thing that we did was write your nodes. One of my students in my previous class said the clues. So they said first we wrote down the clues. In this case, the knowns or the clues were the 2 points that we wrote down. X1 and Y1 was 3 boxes of cookies and $14, and X2 and Y2 was 5 boxes of cookies worth $22. And when we were looking at the problem, we made sure that we labeled those important pieces of information. So in this case, it was X1 and Y1 were the important things. And in other problems, it might be, for example, a slope might be the important thing. But whatever the clues are, the knowns, you write them down. Once we wrote a table, maybe get a table ready, we use that table to first find the change in Y, then find the change in X. I'm going to call this the rise, and in the next page it's going to be the rise as well. This is the run. So Y is up and down, and so that's the reason why I call the change up and down the rise, and the change in X I decided was the run. The slope, or the multiplier, and then this is how we figured out the cost of each box of cookies. So first you find the blue change in Y, then you find the red change in X, and then you divide those two, and that gives you the price for each cost of cookies. And the cost of each box of cookies goes here in the table. It's multiplying the input. So it was 4 times the input, 4 times the input, 4 times the input. So the multiplier was 4. To find that, you find the change in Y, then you find the change in X, and then you divide. And then the last thing we need I'm going to call that the constant term, which in this case was plus 2 more. And you find that where X is equal to 0. And instead of X, let me put the input. So we needed 2 quantities. There was the black 4. I call that the slope. And it was right here. It was multiplying the inputs. And then I needed the constant term here. And the place to look for that in the table, we called that the tax. And in the table, it's wherever the input was 0. So if you put nothing in, then if there's any number here except for 0, you would say, most everybody said, there was actually some confusion in the class, well, if you put nothing in, you must get nothing out. No, you had to add an additional term here. So 4 times 0 does make 0, but there had to be a plus 2. So this is where you look to find the plus 2. It's always where the input is 0. And we're going to have exactly the same steps when we do how to make a graph to make a function. But before I do that, I have some vocabulary to define here too. We've been talking about functions that all have the form some kind of a multiplier of the inputs plus some constant term. I am always going to label the slope term with a triangle, and I am always going to label the intercept with a star. So go ahead and label whatever m is, I'm going to label with a triangle, and whatever b is, that's the star. M is otherwise known as the slope or a rate, and the keywords are each, every, and per. So for example, the cost for each cookie was M, and then B is known as the y-intercept. It's the constant term. It's the one that you pay once and not over and over. It's the starting term. And you might see it referred to as the initial term or the beginning. And then the last thing you need is what's called the slope formula. And we did it, but we didn't say what the definition was exactly. So the slope was, we know it's the rise over the run, but the way we did it in a table, first we found the change in y, then we found the change in x, and then we divided. So it's the change in y divided by the change in x. And if you aren't using the symbol change, then you can just do it all in one step. It's y2 minus y1, because change means subtract, divided by x2 minus x1. All right. So slope is the multiplier, like for every cookie. So it's multiplying the inputs. Sometimes it's called the slope. It might be the rates. You might look for the word each, every, or per, like the dollars per cookie. And the reason it's like that is because of this divide in the step. And then the intercept is the constant term, like the tax, the one that you only paid once, the +2. It's referred to as the y-intercept, or the constant term, the one that you pay once, or the starting term, the initial fee, the beginning fee, those kinds of things. Pause here if you're not ready to move on, because I'm going to move on to the graph now. So to make sure, I'm not going to put the process column in this time, but I'm going to go ahead and copy the data over from the previous page. So it was boxes cost a certain amounts, and we're graphing a domain between 0 and 7 with an interval of 1. And I want my outputs. Let's see, it was $2 here. I remember that. It was $30 for 7 boxes. 3 boxes was $14, and 5 boxes was $22. And then it goes by 4s each time, so it goes 6, 10, 14. It's working. 14 plus 4 is 18, 18 plus 4 is 22, 26, and 30. And those are the data that we're going to graph. So I am figuring out where the rise and the run is in the graph. So first I want to review where they were in the data again. So in the data, we found the difference between these two. 22 minus 14. I need a little bit more room. So we found the difference between these two was 8. Then we found the difference between these two was 2, and then we divided. So where would that be in a graph? I labeled this the rise, and this is going to be the run. So what would that look like in the graph? First I need to label my domain and range, so this is going to be boxes over here, and cost. So first step 1 is to label the words, and then I'm going to divide the domain up so that 7 goes over here. And it looks to me, if I counted every one, then I wouldn't get 7 to be all the way over there. So I'm going to skip 1 each time. So 0, skip 1, 1, 2, 3, 4, 5, 6, 7. Okay, that worked out well. And then I'm going to put the maximum number in the y value up here at the top of the range. And so 30 needs to fit up here. So what would that be? Some people tried by 2s last time, and I don't see how counting by 2s is going to work, at least on mine. Actually, it might. So 10, 12, 14, 16, 18, 20. Well, they were right. 22, 24, 26, 28. It doesn't quite put 30 right up at the top, but it's very close. All right, so we're ready to start putting in our data. The first data point was 0, 2. Now that's an important data point. It's where the value of x was 0. Remember that we gave that a special word. We said this was the tax, and it was the amount that you had to add to the function. So the function was 4x plus 2. That's where the plus 2 comes in. So I'm going to go ahead and label that with a star. Every time I see this is the y-axis, here is the line. Where the line runs into the y-axis is this right here. And so that's the reason why I call this a y-intercept. And I'm going to abbreviate that INT. It's where my line is going to intersect with the y-axis. And it happens where x is equal to 0. It has to be that x, this value, is all the way down here at 0. And I'm only going to plot a couple more of those points so that I can connect them. See, let's see, 3 and 14. 3 was 14. And 5 was 22. 5 was 22. And then I can connect all those with a line. All right. So when I was looking at the table, I literally subtracted 22 minus 14, and that gave me 8 for the rise. When I am using a graph, my first step is going to be to draw what I call a slope triangle. So I'm going to draw straight up from the first dot. So I pick 2 points, this point and this point. I can pick any 2 points that I want to on the line. I go straight up from the first point on the y-axis, and I label that the rise because it's going up and down. And then I'm going to go straight sideways and label that the run because it's going from side to side. And this is called a slope triangle. Oftentimes teachers will draw like a little guy and he's running side to side, so you can remember that this x value, the change in the x values, is always the run because the x1 is the axis that goes side to side, and then the rise is up and down, just like the sun rises up and down. And again, that's the y-axis. So if I wanted to label these, I would label this the change in y because this was the y-axis, and I would label the other one the change in x because that's the x-axis. Okay, so I'm counting by 2's up and down, and so I'm going to count for my rise in this particular case. So each one of these is going to be 2. So I start on 14 and I go 2 to 16, 2, 4, 6, 8. So up and down I go 8s. Well, that makes sense because my rise before was 8. The difference between 14 and 22 in the numbers is 8s. In this case I did it graphically and I did it by counting. So using the graph you can just count your boxes going up instead of subtracting 22 minus 14. So using a graph you can just count going up instead of subtracting. And the run, I'm going to do the same thing, but let's see, these each I was skipping 1 is going to be 1, so it's a little bit more difficult to count. So I'm skipping 1, count 1. So from 3 to 4 that's 1, 2. Okay, so the run is 2. Alright, so if in a table the way to find the rise and the run is by subtracting, and in a graph the way to find the rise and the run is by counting. So I can go ahead and calculate the slope now. Slope is the rise over the run, which means I'm going to divide 8 divided by 2. And that's 4. Alright, so I have now found the rise and the run using my slope triangle, and I have labeled my y-intercept down here. It's where the line ran into the y-axis. It occurred when x was equal to 0, and that was equal to 2. So I know that the slope was 4 and the y-intercept was 2, and that means I can, instead of just using my common sense brain like I did on the last page, I can fill in my equation here. The y is equal to the slope times the input plus the y-intercept. I know that the slope was the rise over the run, and I know the y-intercept happens down at the bottom. And that means I can write an equation without filling in the process column. Y equals blank x plus blank. The term that went here was the slope, and the term that went here was the y-intercept. So here is the 4. Because that's the rise over the run, and then the y-intercept was 2. So my final equation is y equals 4x plus 2. So 4 times the input plus 2 more. And I can do that with a graph without filling in the process column. So a process column is really important so that you realize like why you're multiplying the input, why it was times 4 times the input, and then plus 2. And then a graph is totally different. You can find the rise and the run by looking at the picture. You know that the slope is what multiplies the input. The slope is always in front of the inputs, multiplying it. And then the intercept is the number that you start with or that you begin at on a graph. So in using the graph, my equation is 4 times x plus 2. And using a table, my equation was 4 times the input plus 2. So my summary for a table was write down your notes, get the table ready. First you find the change in y by subtracting, then you find the change in x. The multiplier was when you divide those two things, it was the cost of the cookies, and it multiplies the input like here. And then you have to add a constant term plus 2, and you found that where the input was 0 plus 2. Using a graph, first you find the change in y by counting, in this case it's 8. Then you find the change in x, it's 2. You divide those to find the slope, and the y-intercept is the number that it starts at where x is equal to 0. So it's exactly the same steps, but the representation is completely different. Set up your graph. First, draw a slope triangle. Draw a slope triangle. And shade it in, because a lot of the time if you have a nice shaded in slope triangle, it makes it easier for you to see what it is that you're counting. So first you draw your slope triangle. Okay. First. All right, and then the intercept, or the constant term, and lastly you fill out the form y equals m times x plus b. All right, so two completely different ways of finding a function, one using a table and one using a graph.